3D printing is a wonderful tool for rapidly prototyping your amazing ideas. Unfortunately, misinformation and stupid mistakes lead to catastrophic and expensive failure. Nobody wants spaghetti. This video intends to teach you the very basics of 3D printing in the Maker Lab, Rose Hulman's very own workshop for personal projects. We'll be using the Ultimaker 2 for our demonstration, however there are other printers you can use. The general rule of thumb is if you throw a wrench in the Maker Lab, you're bound to hit some kind of printer. Even if you already know how to 3D print, it's important to watch this video to understand the Maker Lab's 3D printing workflow. And also I put a lot of time and effort into this video, so... The first step in any successful print is leveling the build plate. To do this, simply select Maintenance and then Build Plate. The Ultimaker will then guide you through the steps necessary to level your build plate. The first step is to get the build plate relatively close to the nozzle. Make sure it's not touching. As you can see from the back of my head blocking the camera shot, I'm looking very closely to make sure the nozzle is about a millimeter away. The next step is to use the screws on either side of the build plate to get the nozzle roughly the same distance away at those points. Next, grab your calculus homework and slide it between the nozzle and the build plate. Slide it around and continue adjusting until you feel a slight resistance. Repeat this on the corners using the screws. Now the bed is level. Fantastic. If you decide that you don't like the color of the currently loaded filament, you can change it by selecting Material, then selecting Change. The nozzle will warm up for easy extraction, sped up here with the magic of video editing. Once it's hot enough, the machine will reverse the material all the way out the back of the machine. Once removed, click the button to begin material intake. Feed the new material in until you feel the machine has a nice grip on it. Then, click the button again, and the machine will forward the material all the way back to the hot end. Wait until some material comes out of the nozzle. This may take a while, but when you're editing a video, anything is possible. Tell the machine what kind of filament you just loaded, and you're ready to go. To slice your STL file into G-code, use Ultimaker's free tool, Cura. Load the STL file into Cura. You can see pretty much exactly how your object is going to look on the build plate, and it gives you a pretty good idea about the scale of your object. I think I want my cat to be a little smaller. Cura gives you an estimate on the time to print and material usage in the top left corner. Okay, maybe I want it a tad bit smaller. Once you're satisfied with the positioning, sizing, and rotation, you can change the settings on the side. I want my cat to be detailed, so I'll use thinner slices. Everything else looks good though. I generally don't mess around with the speed of the print. Once you're happy, save the G-code. To upload to the printer, navigate to the Octoprint instance for that printer, then select Upload. Upload your G-code, and then click the button next to the print job to load and print it. You can see here the bed and the nozzle warming up. In the Control tab, you can manually control the printer. And in the G-code viewer, you can see in real time your job's progress as a toolpath. Once the bed and the nozzle have warmed up, your print will automatically start. When your print completes, wait for the bed to cool down before pulling your object off. Isn't it cute? Also, be sure to delete your file off the print server when you're done with it. There are several things you shouldn't do with the Maker Lab's printers. First off, it's important to note that the Maker Lab is for personal projects only. If you have to print something for a project pertaining to another club, there are other 3D printers on campus for that. You also shouldn't use the SD card to print things. That way, if someone wants to start a print job remotely, they can see someone is currently using the printer through the Octoprint interface. Also, if there is a webcam looking at the build plate, don't move it. You should always watch your job for either success or failure and remove it from the build plate whenever either of those occur. You also should never unplug or turn off the printer or the computer controlling it. I hope you enjoyed this brief overview of the printer workflow in the Hulman Maker Lab. If you have any questions or requests, talk to Tim Balls, Luke Gelfus, Connor Crenshaw, LaShawn Lee, or Tucker Osmond. That's me. Thanks again for watching.